Hello friends, today we are going to talk about a new emerging topic of mobile computing, which is known as mobile crowd sensing, where the computation of the mobile network crowd is considered as an input. So it is known as also crowd computing. So mobile crowd sensing is a technology, is a 8 years old, started in the year of 2011 by an Indian scientist, Professor Ganti, and he has developed a model of mobile crowd sensing where the crowd is considered as an input for as in your mobile device, where we can sense all the data around us. You know that mobile has explosive growth in the recent years, where we can see that every user, everyone, every human being using the mobile phone, because it became cheap, it has become affordable, and moreover the growth of internet technology over your mobile phones helps us to integrate the sensing operations using the mobile phone along with your cloud network. So mobile crowd sensing, definition wise, it is individuals, that means human being, with sensing and computing devices. That means your mobile phone as a computing device collectively share the data and extract the information out of it to measure and map the information to the people of common interest. That means we have a common area of interest or region of interest where the data we want to capture using our mobile phones. So the mobile phones are controlled, rather used by the user, that means the human being, and ultimately we have to transfer the data to the service area using the mobile cloud network. You know, the cloud computing is an integrated part of our mobile servers, where we are capturing certain information of certain area. Say for example, this region is a Salt Lake area where we are capturing the data of the Salt Lake. Say it is BF block, we are capturing data of the user, their activities, of the cells and the zones, and ultimately we publish the data based on the user activities. Now it's a very interesting story regarding this mobile crowd sensing, which will make us to understand how this mobile crowd sensing works. So this is a famous Boston bombing problem, where there is a bombing during the marathon race, where the user, we can see they are participating in a marathon and there is a bombing happens, but it was difficult for the police to track who is the bomber. So ultimately they take the help of the mobile cloud computing experts, to resolve this problem. And what happened, they came and they have observed the data of the mobile network, and they have seen the motion of the user having the mobile phone, and they have observed out of the several lakhs of people available there, only few are, say 6 is not moving fast, and others are moving in a random fashion. When there is a bombing, everyone moving in a random fashion. That means 6 is a part of the culprit. So they have detained 6, and ultimately they found that 3 of them are fat, that's why they cannot move. Other 3, they are the culprit, and ultimately police track those people because they know the second bombing will not happen, that's why they are moving slowly. So by this process of capturing the data of the mobile movement of the user, mobile crowd sensing can solve this kind of problem. So this is one of the very interesting example of mobile crowd sensing. You know, sensing is happening in various ways for last 100 years. You can see earlier we have only human perception, we can touch and feel. Then we have developed, scientists have developed the physical sensors, which is basically a transducer which converts non-electrical signal to electrical signal using the transducer. Then after that we have industrial wireless sensor network, where intelligent sensing, okay, where mobile and cloud, they are all combining together. And rest, presently in the year 2020, we are all talking about smart sensing, that means industrial IoT using mobile crowd sensing. So mobile crowd sensing is the future sensing capability of using the mobile phones. You know, the mobile computing is one of the promising area where mobile devices are performing the computation within your mobile phones, and that can do lot of operations. It can do lot of executions, number of applications in a single device. That is the advantage of mobile computing. So all the computations are happening within your mobile phone, but there are some limitations. What are the limitations? You can see the battery life is the biggest problem of mobile phones. So we can see we have mobile phone battery life is limited, so we have to use the cloud network to help the mobile networks. And you can see that there are various types of cells are there: macro cell, micro cell, pico cell, and femto cell. Macro cell is long distance, micro cell is smaller, 1 kilometer, pico cell is 600 meter, femto cell is only 20 by 20 meter. Small coverage means we can precisely use the cell location to find out the certain area of interest where certain events are happening. Okay, you can see there are 4 limitations of these mobile devices. As I mentioned, that there is a limited battery lifetime of mobile devices, there is limited storage capacity of the mobile device, limited processing power of mobile device, and low bandwidth. So these are the 4 limitations which has been resolved by cloud computing, which is known as mobile cloud computing. Cloud computing, as you know, is a virtualization on demand service, pay as you go basis, where the data is stored virtually in the cloud. So we are storing the data from mobile data to the cloud. You can see the cloud computing or the mobile cloud computing is a convergence of the mobile group and cloud group. Ultimately, the mobile based cloud is monitoring all the tasks, and task resource are allocated according to the resource manager, and application manager controls the resource task as well as dispatch operations. Ultimately, whole the data is going to the social network or big data analysis performed, and through the data mining we are finding out certain patterns using our mobile cloud platform. Sensor cloud means when the data is going from the sensors is going to the cloud. This is our real experimental platform in our university system. We have used our sensors to capture the data, and ultimately it is going to the cloud. So it is known as sensor cloud, which is applicable in healthcare industry, also in parking sensors, smart parking, traffic lighting, entertainment, security, everywhere, yeah, as well as in agriculture, factory, everywhere this sensor cloud is playing a major role in this mobile cloud computing platform. So as we can see, it is the mobile cloud computing is basically the common area of mobile and cloud computing, and which is very powerful and which is used in our mobile crowd sensing applications. As we see, the cloud is basically a data center which is a long distance away. Now near to us we have fog devices with the servers within our local campus or university campus, and the low end we have lots of IoT device which is directly integrated to the edge cloud or edge devices. Edge devices means your mobile phone is also an edge device which can compute certain operations, taking the data, sensing certain operations, and it can perform the storage like cloud. But what is the advantage of, instead of using the big cloud to edge, it can perform faster because it is closer to that. Latency, the delay is low. If edge cannot perform, then it go to the fog. You can see the billions of edge devices are there, and fog devices less, in millions, and cloud is in thousands. So when you're talking about mobile crowdsourcing, in order to increase the efficiency and decrease the delay, we have need to use fog and edge devices more and more. So this is a simple definition of cloud sensing, where it is elastic computing between the mobile and cloud network. So we can see the basic architecture of mobile cloud sensing is mobile device, network service provider, and the cloud. One very important thing is the internet. Internet must be available to the network, otherwise cloud sensing is not possible. Yes. So we have 4 operations like mobile network, internet service provider, cloud service provider, and application service provider. They form this mobile cloud network, MCC network. So when you are talking about mobile cloud sensing system, we can see the phones are acting as a sensor. Then we have local sensing, as well as we have remote sensing facilities. Local sensing means which is sensing happening here. Remote sensing is a sensor mapping which is available through the internet to the other end of the city or other end of the locality. Ultimately, all the tasks are going to the cloud sensing platform. And cloud sensing, there is a middleware, and middleware sends the data to the mobile phones. By this process, we are having sensing as a service. Sensing as a service using this mobile phone. That is a application of mobile cloud sensing. So we have various kinds of sensing devices like smartphones, music player, in-vehicle devices as a sensing platform. So we can see why is mobile cloud sensing is everywhere. Sensors, because sensors are available. This mobile phone has lots of sensor inbuilt within the device, and people we are using gathering the information using these mobile phones. Now the cloud sensing has 2 classifications, rather categories. One is called participatory sensing, another one is known as opportunistic sensing. Participatory means, for example, today I am in this room, we are discussing about certain operations. So this is participatory sensing, where people will participate in certain event. They will capture the data using their sensors or the mobile phone sensors. And opportunistic sensing means it is just on the way. Say I am coming to the Salt Lake area through the Ultadanga. I have supposed to see any accident, a car accident. I can capture the picture of the car and simply post to the social network. What will happen? The people who is passing through that road, they can avoid the road, and by this process they can save the time. So this is known as opportunistic sensing. So opportunistic sensing means we are getting the opportunity to see the event, and accordingly we are reacting. Accordingly we are sensing and posting the data to our networks. But participatory sensing means we have to actively participate in the network. There is a 2 difference between participatory sensing and opportunistic sensing. So ultimately, when we are talking about these 2 sensing operations, what is the problem is that participatory sensing has a lot of cost factor involved, because you have to participate in certain event, and a lot of cost is involved here. And opportunity sensing is less costly because we can see these operations or the event nearby you, ultimately filtering the data and bringing a data set for your next generation pattern finding. Now this mobile crowd sensing, this MCS phenomena can be individual or it can be community based. Individual means user movement pattern. In our mobile phones we have movement sensors, so we can see how much steps we are moving, how much heartbeat we are having. All the kinds of movement can be predicted, rather can be measured, can be modeled, and can various kinds of activities like transport and activities can be monitored. Community means a lot of people can come together. Say for example, in a pollution in certain area, that can be, or in noise, that can be measured in a real-time pattern. Also the potholes in the roads. What will happen? The lots of cars are moving. In every car there is a mobile user, so they can feel the vibration of the road, and accordingly the data will go to the transport authority or the municipality, and they will take care of these kinds of problems. So phenomena is two types: individual and community based. Now, various applications are there in MCS. What is called environmental application, where the natural environments are playing a major role, and there is a infrastructure, public infrastructure like road conditions, bridge health conditions. Bridge health monitoring is one of the very important area in our research, because that can cause a lot of health hazards. So using this mobile crowdsensing, we can take care of the infrastructure of the railway bridges. Like Indian Railways are maintaining this infrastructure, can be maintained by through using this MCS architecture, and in the social platform where personal data can be sensed and used in the business applications like Flipkart and Amazon and everywhere. Now that means this basically MCS is one kind of IoT system where we are all sensing, communicating, and we are basically deploying all the sensors virtually using our mobile crowd sensors, and basically it is called IoT, Internet of Things. That means we can access it anywhere, anytime, in any place. So it is known as human IoT as well, because human is in the loop. So when you're talking about crowd as a network part, so it is also known as human IoT. Now these are the several applications areas of this IoT area, where you can see everywhere. If you use like building, energy, consumer, healthcare, industry, retail, security, network architecture, where every people can take the participate in this network, and every crowd can sense the data and build the infrastructure in a proper and efficient manner, with almost without any this business involvement, because mobile phone is freely available to each and every user. So it is basically acting as a virtual sensor, and they're helping in various device locations, applications, as well as in the service sectors. Now there are major challenges, although just it is a 8 years old technology. So there are several challenges are available. First called localization challenge, where we can see the local data analytics of certain area, certain geographical area can be tackled. Resource limitations means we have to recruit the people, those who will participate in the nature of building of these MCS applications. So we have to recruit the people, good people, they will participate in the MCS application to get certain pattern out of it. Privacy is one of the major area, because those who will participate, their privacy must be preserved. That is a very interesting research area. And aggregation analytics, how to aggregate various data and how to build up the total architecture. These are the 5 major challenging areas of mobile crowd sensing. Localized analytics, which is talking about basically local data and local, that must reduce the processing time of the platform to perform certain operations. So there must be dedicated people allocated to certain local area, so to perform certain local analytics. Okay. So mobile crowd sensing has various applications, apps are here, and each and every app is dedicated for certain area of applications. So we have to aggregate the apps, and we have to collect the data using the aggregation analytics, using this cloud based integration of this platform, or edge or fog network based integration. We can have the sensing operations to a meaningful application. So multiple applications can be gathered together, and that can be used in a permutation combination manner to find out a interesting pattern out of it. So data mining is one of the very interesting area. Data meditation, data filtering, collaborative filtering is one of the very interesting area for context aware area, where we can use for the social setting to find out the transportation areas and bridge up the gaps. So for example, if in certain local area where the data is not available, you can see the Google Guide is helping, rather requesting the people to give the data, and they are giving an incentive mechanism out of it. Local analytics is so very important area of mobile crowd sensing. So these are the certain challenges for modeling this local analytics. Resource limitation, as I mentioned, that we have to recruit the good people. Good people means those who are giving genuine data. But the problem is there are certain problems like energy, bandwidth, and computational resource. You know, the bandwidth, if everyone want to compute and certain upload the data, bandwidth is limitation. Energy is another factor. Battery life is another factor. So multiple device, they can dynamically operating and they are changing to perform certain tasks in this network area. Privacy, as I mentioned, is one of the very interesting areas called privacy preserving area. So lots of cryptographic algorithms are available, or rather in the blockchain technology is coming up to as a crowd as a block. Every crowd as a block in this mobile crowd sensing area. So it is also known as MCS chain, mobile crowd sensing blockchain, MCS chain. These are very interesting researchers are coming up using this integration of blockchain with mobile crowd sensing. Yeah, these are the characteristics like multi-mode sensing capabilities, deployment in the field, privacy, energy, cost, and efforts. You know, the efforts are very important. If the people do not take the effort to perform certain job, the MCS will not be successful. So these are the key characteristic feature of this MCS. So it's basically double sword. We have to have the intelligence in the mobility using this human mobility pattern, and we can send the data in the cloud servers. At the same time, humans are there basically privacy concern, as I've already mentioned. We have to preserve both. We have to take the human mobility as well as we have to save the privacy of the user. So it is a double sword technology. One side we are having the intelligence, other side you have to preserve the human privacy. So it is a double sword. Yeah, these are unique characteristics of MCS. As you can see in this picture that various applications are integrated in the cloud or the edge platform or the fog platform, where various application stacks are sending data in a multi-threaded fashion, so that various apps can make a single target to have a certain meaningful pattern using this mobile crowd sensing platform. Now incentive is one of the major area, rather one of the very important area. The people will contribute, but why? What is the incentive mechanism to help the people to participate in this mobile crowd sensing platform? So I have mentioned here 6 process. What is the auction? Auction, there is a player will say that who will win, and accordingly the payment will go. Lottery is another process to pay the incentive. Incentive means you have to pay for the services. The payment can be either in terms of bandwidth, or by cash, or by certain facilities. So here auction, lottery, trust. You know, if you have a group of users, say 1000 user you have, and you have 600 user is trusted, their payment is much more compared to the untrusted user. Trust is one of the very important factor. Fourth point is bargain game. There is a bargaining between the user. Using the game theory approach, we can solve to whom we will pay the dollar according to the contribution, nature of contribution of mobile crowd sense data. Next point is a smart contract. Using this blockchain technology, this consensus technology, we can have, okay, you provide me this data, we'll get this much amount of payment, and this payment will be divided among the user who is contributing to certain nature of job. Now last point is market driven. If the supply or demand, if the supply is less, the incentive will be more in that area. So it is supply and demand based market driven incentive mechanism. You know, there is a famous dialogue of our Indian actor Shah Rukh Khan. He mentioned that do not underestimate the power of common man, but it just added that do not underestimate the power of common man when mobile is in their hand. That means mobile is so powerful when it is individually and when it's collectively it is working together. Then mobile phone is a mobile phone based mobile crowd sensing is very powerful. So do not underestimate the power of common man when the mobile phone is in their hand. Okay. Now this is one of the reference of mobile crowd sensing which published in CRC press. Next, so the question is what you have mentioned today, that is the introduction, that mobile crowd sensing is very popular nowadays for our day-to-day applications where crowd is coming into the picture and without any investment. So mobile phones without any investment, it is, you know, everyone is buying of their own and they are contributing to the society, for the society. So ultimately it is going to be a very popular and emerging technology for the next generation. Thank you.